Alright, so lesson 113 is logarithms and antilogarithms. So basically, logarithms and exponents are inverses of each other. So you're going to see logs and exponents can work hand in hand. Alright, so logarithm is another way to say exponent. So here is something you guys are familiar with. 10 squared equals 100. So 10 is the base of the exponent, or of this right here. And 2 is the exponent. When we put it in log form, it's also going to be the answer to the logarithm. And then 100 is the anti-logarithm. So we want to be able to go back and forth from exponential to log and log to exponential. So here we have just generic exponential form. We've got the base, which is a. We've got our exponent here. And on this side, we've got the answer, okay? So when we go in log form, this a is going to go into what's called the base of the log, all right? So that number is going to be right here. And then this is called the argument of the log, all right? So what was the answer to the exponent is going to go in the argument of the log. And then on this side was the exponent. This is now the answer to the log equation. So let's do a few with real numbers. So here's the general one. I have 10 squared equals 100. So this 10 is going to go into the base. The 100 that was the answer goes into the argument. And the exponent here goes on the other side. So we're going to go back and forth. So 2 cubed equals 8, exponential form. If I put this in log form, it's going to go log base 2 of 8 is equal to 3. So the 2 becomes a little base, 8 moves inside the log function, and 3 goes on the answer side. If we're starting with the log form and we want to go to exponential, we do what I call looping it. Alright? So I'm going to start with the base. This becomes the base of the exponent. Raise it to the power of 2, and it's going to equal 16. Okay, so those mean the same thing, the log and exponential. Alright, so right here, we're going to go 2 to the 5th power equals 32. So that's how we write this in exponential form. Alright, here's another one in exponential form. So if I put it in log form, it's going to be log base 3 of 81 equals 4. Okay, you guys try this one. Okay, hopefully you put log base 5 of 125 equals the exponent 3. Okay, you guys try this one. Okay, so 9 to the first equals 9. If you ever have 1 here, you're going to have the same base as argument here. Alright, 41 to the 0 equals 1 would be log base 43 of 1 equals the exponent 0. Okay, so sometimes we use the fact that we can put it in exponential form to solve for x. So right now, x, my variable, is in the argument. So this is a two-step problem. We're just going to put it in exponential form. So 2 to the 4th power equals x. And then we're going to solve it. So 2 to the 4th is 16. And we're done. Okay, on this one we've got our exponent in the base, or sorry, our variable in the base. So we're going to do the same thing, 2 steps. So I'm going to loop it around, put it in exponential form. Y squared equals 64. And we're going to square root both sides here in order to solve for the variable, and we get 8. You can only have positive bases and arguments. So just positive 8. Okay, eventually you'll learn how to do these on your calculator, but for now we're going to loop it. So this time our variable is over here on the answer side, and so it's going to go into our exponent. So 3 to the z power equals 81. So on this one, I would probably just plug in my calculator till I got it. So 3 to the second is 9, 3 to the third is 27, and 3 to the fourth power is 81. So common logarithm is a logarithm with base 10. So if you have the 84 calculator, you have to do a lot of your logs with just this right here. What this means is it's a given that it's a base of 10. So if you ever see any log, so like log 50, whatever it is, okay, and there's no base right here, it's a given that the base is 10. All right, so we're always going to fill in a 10. And we also have what's called the natural log, which is a logarithm with base e. Okay, so e is a natural number. It's actually this number right here, kind of like pi, where it just goes forever. And so you're going to have something like this. And it's the same thing here, where if you have the ln of some number and there's no base, then for this one, it's a given that the base is an e, all right? Okay. So on your calculator, we're just going to use these buttons. So it's on the left-hand side, so you want to look for log of 105. Now, if you have the inspires, when you enter this in, you have to put the 10 there, the given 10. So sometimes there's a number here, a different base besides 10, and you'll plug that in. But if there's no number, again, it's a given 10. So plug in log 10 105 and make sure you can get 2.021. Okay, round to 3 decimal places. On this one, you do not have to put the e here when you plug it into your calculator. You can plug it in just like this. So look for the ln button, which stands for natural log, and just plug it into your calculator, and we get 4.654. All right, so find the value of x in each case. So the first one, x is equal to the ln of 0.0052. We're just plugging this into our calculator exactly like that, and we get negative 5.259. All right, you should definitely write this next one down because we actually have to solve it. So I have e to the x equals 51.4. So what you want to remember with e and ln is that they're inverses of each other. So to get rid of this e, we can do the ln of both sides. And when I take the ln of this side, it cancels the e, and so I get x equals the ln of 51.4. And then we can just plug that into our calculator, the ln of 51.4, and we get 3.940 when we round to 3 decimal places. Here's another one you should definitely write down. We have to do a step to solve. So this is the one where there's no base given, and we want to get this away from the ln since that's where the variable is. So if we put the e there, we can actually put this in exponential form by looping it. So again, the ln has a given e, so e to the negative 4.16 equals x. Okay, this e button is on your calculator, so look for that e on your calculator. It should be right next to the ln. Plug this in, and we get 0.016. All right, so now I have log of x equals negative 4.16. So same thing except for this one was natural log, and this one is log. So for log, right here, we're missing this base. So again, it's a given 10, and we're going to do the same thing where we put it in exponential form. So 10 to the negative 4.16 equals x. Plug this into your calculator. And for this one, I want you guys to do 3 decimal places plus scientific notation here, because you'll have that e on your calculator, which means times 10 to the negative 5th.